This is episode 5 of my progress on the Gumball Advent Calendar. It's time to face the facts. Despite my efforts, I won't have anything ready by December the 1st. It's not even close.
Well, love.
Long story short, there were just too many factors working against the project, from my limited experience with electronics and grand designs to the recent disruption of having to move. But let's get something straight, this isn't the end. While it might have been worth a couple more likes than usual if I made the deadline, it wouldn't be worth rushing the process. After all, I want the final product to be spectacular. This is a silent mode project, and with patrons or without, it makes far more sense to regroup and aim for an even better result next year. Since the last episode, the focus has shifted toward the Advent Calendar's design. Although more work could have been done with the electronics, especially dealing with this expensive 12-volt motor and motor driver, I realized that the design would dictate the electronics. So the original idea was to have the ball either travel down a plinko board or a zigzag path, depending on which side of the gate it fell through. Considering how we could easily see both options, the first thing that came to mind was this unusual diamond-shaped design, a world of difference compared to the initial brick-shaped monolith I had in mind. The general idea was to have a view of both boards from the front, so whichever path the board took, we could see it traveling. If there was any chance of having at least a design before the deadline, I had to think about simplification. I mentioned in the last episode that using sheets of acrylic or plexiglass for the frame would make sense. I really like the idea of a transparent body that reveals the innards of the Advent Calendar, which lends itself well to lighting and the design of moving parts. Just as importantly, it would save on 3D printing time and materials. As Carlos mentioned during his talk at Printed earlier this year, not everything has to be 3D printed. One of the most valuable skills a maker can have is discerning which techniques to use and when. Considering how this Advent Calendar would be produced and assembled, I immediately turned to Ben Heck's approach, designing something that can be taken apart. I decided the best way to design the machine was in modules, individually produced parts that work together. The ball lift mechanism was the first module to work on. I realized that it didn't have to be as bulky as first intended. All it's doing is pushing the ball upwards against the surface. All that matters is that the threads can fit one of the balls. At this point, I had no idea how tall the ball lift had to be. However, I did have the idea to divide it into smaller sections that fit together. Not only would I be able to make the ball lift as tall or short as required, but I could also produce these parts on my A1 Mini if necessary. Another benefit is the possibility of a multicolored ball lift if I produced them in different colors. Where things started to fall apart was with what ironically should be the simplest thing, the ball feed. Having all the gifts in a simple container, as with a typical gumball machine, would conserve the most space. For visual effect, I wanted the balls arranged in a single depth stack, but this reintroduced the possibility of jamming during dispensing, which I obviously want to avoid. The problem is solved in actual gumball machines by using an agitator or a device that moves the balls around inside the container. Right now, I can't figure out how to incorporate this into the current design without eventually reverting to the wheel mechanism. If there was any chance of still making the deadline, I had to simplify the design further. Because the emphasis was on feeding the lift one ball at a time, I eventually decided to repurpose the zigzag path as a modular ball feed. This also reversed the idea for a diamond-shaped machine. Up to this point, I was working at a small scale using 8mm wooden balls. Arseni suggested I should produce the parts at full scale instead, which seemed counterproductive but actually made sense. Although it's faster to 3D print smaller models, many details are easily overlooked, including measurements and settings that don't translate well when enlarged. This becomes especially important to consider when producing the final parts, as we risk wasting time, energy and material if we get just one thing wrong. Because I was still convinced I could meet the deadline, I went right into it with the updated zigzag module. First problem, the model is too big to fit on any of my printers in one piece, which meant dividing it into smaller pieces. My first call was to use Luban to divide the part into modules. I've had success with it on its own for other projects, but the size of this model meant obtaining a trial license. The Luban divided models printed okay on my Ender 3S1, and the measurements seemed just fine. Attempting to put the whole thing together was a different story. A better solution was to divide the model in half in the slicer, with both halves fitting on the printer. No Luban license required. Second problem, print orientation and the use of support material are more important than we think. It's more trendy than common sense for people in the 3D printing space to design models that don't require support material, although we know they can be a pain in the neck to remove. In this case, the remnants of the support material render the print completely unusable without extensive work. What you might not know is that the model's orientation on the print bed is related and just as important. In addition to determining whether a model requires support material or not, it can also impact the final print's measurements and texture. Third problem, imagine waiting for goodness knows how many hours for a print to finish, only to find out you've gotten a key measurement wrong. Thankfully, I just printed one half of the model, and this is a great case for using unwanted or undesirable filament for prototyping. In hindsight, the best strategy would have been to avoid 3D printing and instead start with good old-fashioned materials. As they used to say, measure twice, print once. I've been faithful to my Ender 3S1, which is now called Ancient Technology. However, I've decided to replace it with an A1 based solely on my printing requirements. I've also been impressed with the A1 Mini and was inspired to go for the A1 by Arseni's lab. I pledged only to buy an A1 if I could find one under £200, and I immediately thought of getting one second hand. As luck would have it, Bamboo Lab's Black Friday offer meant that requirements would change. But let's get one thing straight, I'm no panda, and you won't see me badgering anyone into buying a Bamboo Lab printer. Although it's not a fair comparison, this half of the ball feed module took around 15 hours on the Ender 3S1 with a 0.5mm nozzle, and around 9 hours on the A1 with a 0.8mm nozzle. Out of curiosity, I researched how much it would cost to have the ball feed module produced elsewhere. Of the places I found that suggest they can print it in one piece, the quote for 2 copies was just as much as for a new printer before shipping. If it's just a one-time thing and we don't need a 3D printer, or we're not sure we can print the parts in good enough quality, it makes sense to go down this route. As much as I like to pretend everything went according to plan, sometimes it's necessary to take an L. Whether it was being too ambitious, inexperienced, or both, meeting the December 1st deadline was unrealistic. Even without things going horribly wrong this year and circumstances beyond my control, a huge oversight was underestimating how long each step would take. Example circuits and small-scale prototypes are completely different to building full-scale modules and a working machine. With that said, I'm not giving up on the project. The new goal is to have the first version of the Gumball Advent Calendar, complete with build, ready for next December. That gives me plenty of time to make the project as great as it deserves to be, whether it's adding those extra bells and whistles, refining the design, or both. Ironically, the progress made to date could lead to getting support for the project, perhaps even that elusive sponsorship. Above all else, everything you've seen from these episodes was a learning experience for future projects. If you're interested in supporting the Gumball Advent Calendar or other projects, check out the links in the video description and maybe become a patron. The very least you can do is give this video a thumbs up, or maybe a thumbs down because I should have a finished product by now. Until next time, this is Silent Mode, maker, artist and LEGO enthusiast, encouraging you all to do your thing.